All right. And we are back live. Wonderful once again. Okay. So y'all just got back from this wonderful lunch period. I don't know, day 2, I'm assuming it goes a little bit smoother or whatever, but like, are they actually able to keep you guys separated in those locations?
They try. In the gym,
Yeah.
you can have like 4 people at like a table.
Yeah.
There's 30 people on the bleachers.
Fun stuff.
On like one row.
And now on Thursday, somehow they're going to split you guys up between indoor and outdoor, weather permitting. Really? So, okay, every indoor location has not a cooperating, but a connected outdoor location. For example, in the main gym 1, I think the outdoor location is the football field. And then I think main gym 2, I actually don't know where that is. I think it might be courtyard 1 or something like that. I don't know. But then like the library was supposedly connected to courtyard 2. Where is courtyard 2? Right down there. They had picnic tables there last week, took them away. I don't know. We'll see what happens. Anyway. So this is the first 84-minute period we're going to have, including that intervention period. I'm sure you've already gone through some of those intervention periods with other teachers. I just wanted to explain exactly what is expected of you today. First and foremost, I will give you a couple of reminders. Number 2, I am going to be teaching the lesson, the actual full lesson on graphing rational functions. Last class, I introduced things, but today we're actually going to be deep diving rational functions and some of the things that you are going to have to do. But then for the intervention period. Now, our intervention period, 23 minutes, teachers can opt to take them at the beginning or the end. I am opting to give it at the end, which means that the intervention period that we would be giving would start approximately around noon, and it'll go from noon to about 12:23, and that would be the end of the class period. I believe 12:23, right? Yes, 12:23. Now, today, as you've probably already done in other classes, we are going to be taking the pre-assessment. The pre-assessment, first and foremost, not a grade that will count against you, but the pre-assessment that you will take will place you either into the remediation group or in the enrichment group. What they have is 6 questions that you will do based on old material in this class. And if you score 4 or better, 4 correct, 5 correct, 6 correct out of 6, then you will be the enrichment group, or in Linkit, it'll actually list you as mastery. But then if you score less than that, if you score 3 or 2 or 1 or 0, then you would be placed in the remediation group, in which there would have to be some level of remediation. The pre-assessment does not count against you. But the things that you do either in the remediation group or in the enrichment group, those will count as minor assessments. So there will be grades coming out of this intervention period that are in addition to our regular grades, which is great. Fantastic. So for those of you that are online, keep in mind that we will be doing a pre-assessment around noon, and I do have a code that you need in order to complete that via Linkit, which I will put on the board at that time, and we will knock that thing out. Again, this is a pre-assessment. The pre-assessment does not count against you, but obviously if you don't want to be in the remediation group, then, well, score as best you can, I guess, so to speak. But again, this individual grade doesn't count against you. I will tell you, it's roughly, I don't know, not exactly 50-50, but amongst all the classes that have taken it so far, it's like 60-40, 60% mastery, 40% non. Well, we'll see what the heck happens. Okay. Before I forget, for those of you in the chat, obviously leave a comment. That'd be fantastic. Joe says, I think it's near the labs. Where are the labs? He means like the science labs? I don't know. I don't care. No, I had mentioned before about the courtyard too, and he said, I think it's near the labs. I don't know what that means. Maybe he'll comment. But if you haven't left a comment in the chat, please make sure that you do so. That'd be fantastic for my attendance. First reminder, you have an online minor due for me tomorrow. You have a quizzes. That online minor is due tomorrow by 7:30 in the morning. Several people emailed me from the other class because theirs was due today. And they emailed me saying, Mr. Markey, it wouldn't let me go on. And I'm like, yes, because the code expired at 7:30. Get on that. You got 2 attempts to get that thing done. Make sure you are knocking out that online quizzes. For you, it is due tomorrow. Now, we are going to be jumping into some graphing stuff. I'm going to be walking you through what is going to be expected of you. And then, like I said, at noon, we're going to knock out that pre-assessment. Should be a pretty straightforward day. So if you would, those of you in the chat, and basically all of you here as well, if you do not already have them out, I'm going to need those notebooks out and open. Let's see what we do here. I am going to walk you through a progression of steps. But those steps are all going to be involved with an example, one example that I'm going to stick with for a bit. Then we will try it again with another example. Come on, this thing. There we go. Today is the 27th. And I'm calling this graphing rational functions. Now, you will have either the calculator or Desmos or whatever to graph these things for you. However, it will be your responsibility within these problems to identify certain pieces of information, whether they be the table of values, the asymptotes, x-intercepts, things of that nature. It is going to be your responsibility to identify those things as we go along. What do you call it? Yesterday was my daughter's birthday. She turned 3 years old, and I'm just going to brag with some pictures because it's wonderful. Look at her face right here. She is going to be a movie star one day, and I'll show you why in a moment. Watch it focus. There's her face right there. There she's smiling. Boom. There she is again, making another pose. She's just posing. I don't know why. I didn't even tell her to do this, but she just started doing this when the camera came out. Look at that face. Look at that face. Look at that face. That's the type of face that will be holding an Oscar one day. Right there. Just smiling naturally. I don't know what she was doing there. I think someone was tossing popcorn at her or something. Anyway, but that's my daughter. No more daughter pictures. Back to graphing. Typically, a rational function is in the form f of x equals this fraction. Typically, a rational function is in that form. Now, what's important to know about that form, it is a single fraction. It is a single fraction. Now, sometimes you will be given problems where they are not single fractions. They're going to be multiple fractions either being added or subtracted, or multiplied or divided. It is your job to simplify that fraction first, to simplify the multiplication division, or to simplify the adding and subtracting until you get a single fraction, just like we've been doing for the past 2 weeks. With this problem, again, a rational function is typically in this form. Now, let me give you an example of one. This example we will be working with for the next little bit of time. F of x equals the fraction x plus 4 over x minus 3. Now, this is just a very basic, simple example that's being thrown at you. What I need you to recognize is the top and the bottom of the fraction could be considered their own equation. For example, if I just gave you x plus 4, that would be the top of the fraction. That would be the p of x. If I just gave you the bottom of the fraction there, the x minus 3, then that would be a different fraction, a different equation, a separate equation, the q of x. You can consider each of them separate within the fraction, because that's going to help you identify various pieces as we move forward. Now, p of x and q of x, meaning the numerator and the denominator, have degrees, and we've talked about this in the past. They have degrees determined by their exponents. Or I should say, by their largest exponent. I'm going to sneak that word in there. By their largest exponent. Let me zoom in on that. They have degrees, and it is vitally important that you are able to identify, after everything is simplified, of course, which it is important that you identify what the degree of the top of the fraction is versus the bottom of the fraction. Because whatever the degree is from the top of the fraction to the bottom of the fraction is going to inform what you do next. Just for the sake of argument, and I'm going to put this on paper in red. The largest exponent for the top and for the bottom is 1 for this example. Just for this example. The exponents, the degrees, I should say, are equal to one another. In the end, there's going to be 3 cases. We are mainly going to be dealing with one of those cases today. There are actually 3 cases of exponents. First case, when they are equal to one another. That is the case that we are going to be focusing on today. That is our main focus and goal of today. What happens when the exponents, the degrees of those 2 polynomials, are equal to one another? The other 2 cases are when the numerator has a larger degree and the denominator has a larger degree, but we will be dealing with those another day. I may give you a couple pieces of notes, but we're going to be dealing exclusively with this type of example today. We're going to be taking a look at it. Now, after I write down this next step, I am going to be jumping to Desmos to show you an example with this problem. It's going to be wonderful. The next statement is this. If the degrees are equal, we're going to be dealing exclusively with this type of example today. If the degrees are equal, then the ha, and notice I'm capitalizing that. We'll talk about what that is in a moment. But if the degrees are equal, then the ha will be the leading coefficients of P of x divided by Q of x. Now, what the heck is ha? is the question. I'm going to put that over here. I'm abbreviating it because it's a lot easier to abbreviate ha. It's a lot easier instead of writing out what it actually is. And when you do this for me, when you do future problems for me, I don't expect you to write out the full words, but just know that ha is always referring to the horizontal asymptote. It's always referring for the horizontal asymptote. Now, I'm going to have other abbreviations later on, but let's actually do that for this example. Let's actually do that for this example. So let me scroll down a little bit right here. Back here. There we go. There's our example right there. There's the f of x that I was dealing with. There's the example that I want to focus on. We talked about the degrees. Well, if the degrees are equal, then the horizontal asymptote will be the leading coefficients of p of x divided by q of x. When I am referring to the leading coefficients, let's even get purple here. I don't know if purple will show up as a colored pencil. Ooh, green. Green might be better. The leading coefficients right here, did that show up? It kind of showed up. Okay. The leading coefficients here on the top and the bottom of the fraction, on the top and the bottom of the fraction, are 1 for this example. They don't have to be 1, but for this example, it is 1 over 1. The horizontal asymptote will be the leading coefficients of p of x over q of x, in this case, 1 divided by 1. I'm going to Desmos. This example, I'm putting right into Desmos, and I want to see that. I want to see what the heck this thing actually looks like. So let's go to Desmos real quick. Again, Desmos may be helpful for future endeavors. There we go. There's the example that we have. I just typed it in, x plus 4 over x minus 3. Try to zoom out just a tiny bit. There we go. So you can see those red lines curving around, just like we saw last Friday. But I'm going to type in a second equation. I'm going to type in a second equation. Y, come on, you. Y equals 1. Look at that junk right there. Look at that junk right there. Let me zoom out a little more. Look at that green line slicing through the middle of those equations. This is my horizontal asymptote. Notice, it's going through positive 1 right there. That is exactly what that definition said it would do. The horizontal asymptote would be, well, a horizontal line through y equals 1, or the leading coefficients divided by each other. Again, notice the graph is coming down and it is flatlining. It is flatlining right at that horizontal asymptote, and the graph on the other side, if you go to the left, is flatlining on that horizontal asymptote. If the degrees are equal, you can determine the horizontal asymptote by that definition. Bring that larger, there we go. If the degrees are equal, then the ha will be the leading coefficients of p of x divided by q of x. Next bullet point. If you set the denominator equal to 0 and solve, you get va. Now, please use your context clues here. You can easily figure out what the heck I'm talking about when I say the word va. What am I talking about? What am I talking about? What the heck is va? Ooh. I don't know. I'm going to leave that up there temporarily. I guess we'll have to determine what the heck va is in a moment. Because I'll have to tell you what it is, obviously. But this problem says, if I take the denominator and set it equal to 0, then it should give me whatever the heck va is. Well, the denominator, was it plus 3 or minus 3? It was x minus 3? Okay, just wanted to confirm. That would have changed my va. X minus 3 equals 0. It's the hardest question you'll get all day. How do I solve this? Oh, Mr. Markey, it's very simple. You just kind of stare at it and hope for the best. No. No. Oh, that looks strange. Sorry, have you ever looked at equations like by turning your head to the left or to the right just to try to see it like that? Like, look, if you just turn your head like this, it just looks strange. I've seen junk like that before. But anyway, regardless. Clearly, if you just add 3, you get whatever the heck that is. Supposedly, it's what I've been referring to as your va. What the heck is that? What is va? It's your vertical asymptote. If you set your denominator equal to 0 and solve, you get your va, or your vertical asymptote. Now, let me go back to Desmos with this example, because I want to stick with this example. I'm not leaving this example alone just yet. Now, watch what I'm about to do here. X equals 3. Look at that. Holy crap, that x equals 3. Look what it did. It created a vertical line through x equals 3. And look what the graph does. The graph, when it goes up to this purple line, it flatlines. But it flatlines in a vertical direction. Then look at this other side. It's flatlining again in that vertical direction. It is a vertical asymptote, an invisible barrier that the graph approaches but doesn't cross. It doesn't cross. It's going to be important. It's going to be very important moving forward. Unbelievably important moving forward. Especially for some of the examples that I have in store for you. Let me go back here. Third bullet point. It's the last bullet point in this set so far. If you set the numerator equal to 0 and solve, you get the pause for dramatic effect. Now I want you to listen to the recap real quick. If you take the leading coefficients and divide them, in this example, you get the horizontal asymptote. If you set the denominator equal to 0 and solve, you get the vertical asymptote. And there's a reason for that. You can't let the denominator equal 0. If the denominator is ever equal to 0, then it can't exist. You can't divide by 0, which is why the vertical asymptote occurs there. But if you set the numerator equal to 0 and solve, you get the x-intercepts. We've been dealing with x-intercepts since literally September. finding x-intercepts, solving for x-intercepts, determining where the x-intercepts occur. They are vital. Now, in this example, again, I'm still sticking with this example. It's frozen like my heart. There it is. If I stick with this example, and I decide that I want to identify, where'd that red marker go? I threw it back over here. Come here, you. If I set this numerator equal to 0 and solve, I can find my x-intercepts, which clearly I just get a -4. But let me go back to Desmos. With this example, let me get rid of this line right there and look right there. I'm going to zoom in on this. Zoom, 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 zoom. Oh, too far. Come on, go back. There it goes. Oh, gosh. Whatever. I'll click it right there. If I click that, you can see that right there, -4, 0. It's sitting pretty right there. Let me move this over. Yeah, nope, it won't move over. But there is my x-intercept. And according to what I've done, there is no other location on this entire graph. There is no other location other than that -4, 0 where it crosses the x-axis. That's it. That's the only one where it occurs. These are the things that we're going to have to do. So, your responsibilities. Here are your responsibilities for this problem. If you're given f of x equals this dumb equation, you are going to have to identify a horizontal asymptote, which in this case was y equals 1. You are going to have to identify a vertical asymptote, which in this case was x equals 3. You are going to have to identify the x-intercepts, which in this case was x equals -4. And you are going to have to create a table of values. Oh, crap, a table of values. Oh, snap. Hold on, a table of values. I'm going to type something into my calculator. I'm going to zoom in right here. Now, obviously, you have the calculators on your computers. And you have Desmos, but I want to show you how to do it directly on the calculator itself because you have those on the Chromebooks, and they work exactly the same way. You type your equation into the calculator. Notice my use of parentheses. Then, if I need to create a table of values, second graph will bring me to this table of values. What the heck is that? What the heck is that? Hold on. Why is that happening? Where though? That's why. Because, and I'm going to recap what you just said for everyone else. If you plug a 3 in to that equation, the denominator is equal to 0, and it does not exist. Here's the rule of thumb for my table of values. Number 1, you can get the table of values right here. Literally, copy it down. That's literally what I'm going to do, and that's what I'm going to expect you to do moving forward. You want a table of values? Get it from the calculator. You have to make sure you type it in correctly. But then all I'm going to say is, hey, maybe get a couple of points to the left of the error and a couple of points to the right of the error. So all I'm really going to copy down is this. I'm going to copy down 1 and -2.5. I'm going to copy down 2 and negative 6. I'm going to copy down 4 and 8. And I'm going to copy down 5 and 4.5. Let me zoom out, show you exactly what I just copied down. That's just what I copied down right there. That's all I copied. That's honestly all you need in order to graph this correctly. You can get that table of values directly from the calculator. You can get it from Desmos if you wanted to. You just have to know where the errors are going to occur. And those errors are going to occur at your vertical asymptote. Now I'm ready to graph it. Now I'm ready to graph it. And this is what we're going to do. We're going to graph this thing. We're going to graph this thing. We're going to put it on a nice little XY plane. It's going to be phenomenal. Let me put this aside temporarily. Move this piece of paper in. Let me create a little XY plane action going on here, because you're going to have to graph this thing. There's my graph. First, I'm going to put my asymptotes on there. Let's see. Boom. There's y equals 1. Now, asymptotes are supposed to be, they're supposed to be invisible. Clearly, I'm not going to draw an invisible line, but I can indicate the asymptote by a dashed line. And I'm going to suggest that you do the same. Indicate it by a dashed line. For the vertical asymptote, again, same thing. I'm going to indicate it with a dashed line. Those are my two asymptotes. Again, dashed lines are kind of the universal symbol of asymptotes in this case. The graph is not exactly equal to it, but it's kind of approaching that barrier. I'm going to plot my x-intercept. I'm going to plot my x-intercept. I got that for a reason. There it is right there. There's my x-intercept. Make it a little bit, I'll make it a little bit more obvious. There it is. Then I'm going to plot my points. Let's see. 1 and negative 2.5. 2 and negative 6. 4 and 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Goes all the way up here. But that's okay. I'll deal with that in a minute. And then 5 and 4.5. 1, 2, 3, 4 and a half. Believe it or not, this is sufficient for drawing my graph. This is sufficient for drawing my graph. Number one, this thing is going to curve downward and it is going to flatline. Zoom out a little. It's going to flatline with that vertical asymptote. To the left, it's going to flatline with the horizontal asymptote. Then over here, it's going to do something very similar, where it's not just going to be a straight line, it's going to be a curve that's going to flatline with the horizontal. And up here, it's not really that visible, but I'm just going to draw a little arrow here indicating that, yeah, it's still going up, but it is going to flatline with that vertical asymptote. All of these little components are needed for drawing this thing. All of them. Wonderful. Absolutely stinking wonderful. This thing. But it fits all the criteria that I'm looking for. The horizontal asymptote at the proper location, the vertical asymptote at the proper location, the x-intercept, the table of values. I want to show you something. I think this will work. I need you to see this. I need you to see this debacle. Check this out. Okay. Zooming in, zooming in. Look at this, look at this, look at this, look at this. On the left, on the left is a TI 83 plus calculator. On the right is a TI 84 plus calculator. The calculators that you have on your Chromebooks are probably as good as the one on the right. Probably better, actually, than the one on the right. I think you have like other additions or whatever. Doesn't matter. But check this out. If I graph this, look what happens. If I graph this, look what happens. What's wrong with this graph? What is off about this graph? Something going on here. Let me go to the calculator on the computer. Let me go to the calculator on the computer because there's something off about this graph that I need you to recognize. Come on. Load it up. That's not the example. Parentheses x plus 4, parentheses divided by parentheses x minus 3, parentheses. This is the one that you have on your computers. Graph. Oh, look at that. That's what it should be. What is so different about what's on these two calculators compared to what's here? These calculators are not as good. The reason being is because these calculators include that vertical line because the calculator doesn't know how to handle it. The calculator includes this vertical line when it shouldn't. That vertical line is the vertical asymptote. And if you draw the vertical asymptote as a solid line, if I ever see something like this, I'm going to draw this in green and I'm going to cross it out with major disdain. If I ever see somebody draw something like this, where it's like, if I ever see somebody draw something like that and they try to submit that for a graph, I am immediately going to mark it wrong. Because number one, it shows me that all you did was copy down whatever the heck was on the screen. You didn't identify any of the asymptotes. You didn't identify any of the ordered pairs. And this line in the middle, you made it solid? Why? It doesn't do that. It's supposed to be a dashed line. It's supposed to be an invisible barrier that the graph is approaching, not that it's actually part of the graph. Cross that out with huge disdain. I got one more big example for today. One more big example for today. And then we can knock out that in pre-assessment. Example. F of x equals x squared plus 2x minus 3 over 2x squared minus x minus 3. That's the last big example for today. Now here's what's going to happen. First of all, I showed you this example last class as a, hey, can you actually type this into Desmos to see what it looks like? And we're going to do that again in a little bit. But first, I want to walk you through those steps that I showed you before with the other example. This one's just slightly more advanced. First of all, the degree of the top and the bottom are equal to one another. They're equal. They're the same degree, largest exponent from the top to the bottom, meaning no definitions have changed. It's the exact same case that we dealt with earlier. So if I actually bring back those notes, hold on. Okay, hold on. P of x and Q of x have degrees determined by their largest exponent. Okay, so the degree of the top of the fraction is 2, and the degree of the bottom of the fraction is 2. Okay. If the degrees are equal, then the half, the horizontal asymptote, will be the leading coefficients of P of X over Q of X. Well, that's a 1 over 2. That's a 1 leading coefficient over a 2 leading coefficient. So there's not much work to be done here for this one. My half should be 1 divided by 2, and it is. That's literally all the work that you have to do in order to get this horizontal asymptote. Make sure that you correctly identify what case it is. In this case, the degrees are equal. And then if you take the leading coefficients and divide them, boom, you have the half. All right, let's talk about a vertical asymptote. If you want to find the vertical asymptote, according to my directions from earlier, if you set the denominator equal to 0 and solve, you get the VA, the vertical asymptote. All right. The denominator equal to 0. Oh, crap. Crap. How do I solve that? Crap. Guess this is a job for photomath. No. You have to factor. You have to factor this. And if you factor this, you will be able to solve it. Now, we've been factoring since September, number one. Number two, I reintroduced factoring to you right after we got back from spring break. Reintroduced factoring. Spent an entire class period on it. Used the factoring when we simplified. Multiplication, division, addition, subtraction. Factor, factor, factor. Let's do it. I'm just going to walk through the Tucker method. A times C is -6. That's a 2 times a -3. My two magic numbers, coincidentally, are -3 and 2 because they multiply to -6 and add up to a -1 right in the middle. I'm going to do a T-chart where I put my magic numbers in the bottom. I got to break it up 2x and 2x. The 2 over 2 simplifies to be a 1 over 1. Vertically, I get a 2x minus 3 and an x plus 1 equals 0. Again, all that I'm doing is I had to set my denominator equal to 0 and solve. I had to do that to get my vertical asymptotes, which in this case, if I solve each of those parentheses equal to 0, holy crap, I get two different answers. I get an answer of 3 over 2, or the decimal 1.5, and I get an answer of -1. Wait, so you're telling me that there are two vertical asymptotes? Yes, there are two vertical asymptotes. Your VA is x equals 1.5 and x equals -1. Holy crap. Now, for the sake of time, I'm actually going to show you a small shortcut. Small shortcut in regards to your x-intercepts. In regards to your x-intercepts, you can actually get them from the table of values. Check this junk out. First of all, if I went to my calculator, I'll try to type it in right here. Clear that. Parentheses, x, that's not an x squared plus 2x minus 3, parentheses divided by 2x squared minus x minus 3, close those parentheses. If you type that in correctly into your calculator, you can get the table of values through here. Notice right here on these two numbers, I have an x-intercept. And down here, I have an x-intercept. They're actually in the table of values. Sometimes. As long as they are whole numbers, you should be able to see them in the table of values. It's a small shortcut, but it's fantastic. Those are my two x-intercepts. I'm going to draw down a table of values here. I'm going to copy down some junk in regards to a table of values. And we're going to see if we can't graph this sucker. Let's see. I'm going to put this to the side right here. I'm going to do -3, 0, -2 and -0.429, 0, 1, 1, 0, 2 and 1.67. There you go, so you can see it. And 3, 1. Those are legitimately the only numbers I need. That's it. That's the, to graph this thing. That and the asymptotes, and I can do this thing. If we did that and the asymptotes, we can graph this sucker. Absolutely 1 billion%. Let's see what happens. Okay. First, my ha is at 1/2, meaning I got to put it there. Make sure you put it in the proper location. Notice how I had it halfway between 0 and 1. I need my va, which is at 1.5. There's my va at 1.5, and my other va at -1. Look at this junk. I have 3 asymptotes on there. That's insane. Now I'm just going to plot some points. I'm going to literally plot the points from the table of values. There's -3, 0. There's -2 and -0.4-ish. There's 0, 1. There's 1, 0. There's 2 and 1.6-ish. And there's 3, 1. Holy crap, how am I supposed to graph this thing? Those 6 ordered pairs and those asymptotes are enough for you to be able to graph this thing. Watch what the heck happens. I'm going to put it in green because I want to. On the far left, this thing is going to flatline. It's going to flatline on the vertical, and on the left, it's going to flatline on the horizontal. Look at that thing. It's going to flatline on the vertical, and it's going to flatline on the horizontal. That's what it did before. Yes. Same thing here. It's going to flatline on the horizontal, and it is going to flatline on the vertical. That's exactly what it is supposed to do. In the middle, there's a bit of an issue. The horizontal asymptote rule really only applies for the ends. The horizontal one doesn't really apply for the middle, and you have this weird exception. Watch what happens here, and then I'm going to show you on the calculator. There's a weird exception here where this thing is still going to flatline on the vertical. Make it a little bit darker here. I might color this in like purple to make it a little bit better. And it's going to flatline up here on the vertical. I'll put it in purple, make it a little bit more noticeable. That purple's not really it's kind of working. But this thing flatlines still on the vertical, but it doesn't do that horizontal thing in the middle. This is messed up. This is 3 disconnected curves on this thing. I'll show you on the calculator in a moment. Look at this thing. Look at this junky thing right here. That's what it does. I'm going to go back to the calculator, see what this thing looks like. Chapow! Graph. There it is. It's got that horizontal. It's got the 2 verticals. It's got that weird thing in the middle. It's exactly what it's supposed to do. That thing right there. It's going to be part of your job. You're going to have to identify the asymptotes, the table of values, graph that thing out. Insane. One last thing I want you to copy down. We're not actually going to go over these examples today, but I want you to have this written down for next time. There are 3 cases for degrees. And we've done one of them so far. Case 1, degrees equal. Well, you divide leading coefficients, notice my abbreviation, to get ha. That's literally all we did for case 1. There are 3 cases for degrees. Case 1, the degrees are equal to one another. You divide LC, the leading coefficients, to get ha. Cool. Case 2. Case 2, denominator has larger degree. If the denominator has the larger degree, then your ha is y equals 0, no matter what, every time, no exceptions. If your denominator has the larger degree, then your horizontal asymptote is y equals 0, done. No work, just identify what the degrees are, and you have the horizontal asymptote. I might show you a quick example in a little bit, but I'm not going to actually have you work through an example. And then finally, case 3, the numerator has larger degree. If the numerator has the larger degree, there is no ha. There is no horizontal asymptote. But there is a slant asymptote. I'm not going to teach you that today. But if the numerator has the larger degree, then there actually is something called a slant asymptote. And I'll show you that visually in a few moments. It's insane. It is legitimately insane, the way that these problems work out. Let me show you on the calculator. Actually, no, on Desmos. I want it on Desmos. Yeah, in Desmos. All right, so check this out. I'll make the bottom larger. Squared. There it is right there. You can see in red. I made it an x squared on bottom. Horizontal asymptote is y equals 0. Make it a cube. Cube. Horizontal asymptote is y equals 0. Make it a fourth. Horizontal asymptote is y equals 0. Doesn't matter. Make the top a square. If I make the top a square, let me get rid of this real quick. Come on, you. There it is. I'll zoom out a little. Notice that if I made the top a square, then all of a sudden there is no horizontal asymptote, but there actually is what is known as a slant asymptote. That's if the numerator has the larger degree. Also known as like an oblique asymptote, but again, I'm not going to teach that today. I'll teach that next time with those cases. They're fairly easy to recognize, especially if you have a calculator to get this thing done. Okay, here's what I need you to do. If you do not already have your Chromebooks out, I need your Chromebooks out and open, because we got a pre-assessment to take. Everyone, after you log on, which obviously for those of you on the live stream are already logged on, but if you are logging on, I'm going to be posting a link into the Google Classroom stream that you will need to take this assessment. That's not us. Let's post this into the stream. There is the link right there. I posted a link into the stream where you are going to go to this page, where you enter your assignment code. You are going to have to do this. I have the code ready to go, just giving people an opportunity to get to this page. Now, when I give you the assignment code, just like all the other things that we've taken, you're going to come to a list of names. You select your name. You click to log on with the name. Your password is your student ID number, no BTS. And then there will be 6 questions. Unfortunately, they're either right or wrong. Take your time. Use scratch paper if need be. You have the calculator on the computer if need be. But this is what we're going to have to knock out. Are we doing? Yes. He asked the question, are we doing this assessment now? Yes. Once I give you the code, you will have the remainder of the class period. You'll have 23 minutes to get it done. Obviously, not everybody is going to need 23 minutes. When you are done with it, you have to click submit, and it will be graded instantaneously for me, not for you. It'd be graded for me so that on Thursday when you come in, I'll be able to tell you what group you landed in based on the scores that you're taking now. Reminder, this score today doesn't count against you, but it will determine for this standard whether you do enrichment or remediation. And then the next time we do a standard, the next time we switch over to a new standard, you will have to take another pre-assessment that would determine whether you do remediation or enrichment. I did not come up with this system. This system is a monster of its own device. There is the code that you need. 001. I'll type it into the live chat in case you can't see it, but it's 001. Here we go. UQJ R4. Type the code into the chat, just double checking 001 UQJ R4. And, well, Once you get into it, you can begin. Like I said, once you click submit at the end, they'll be automatically graded, and you'll be placed either in mastery or non-mastery, but you won't know those results right away. I will, though. Reminder for the chat, the link. There we go. The link to the test taker is in the Google Classroom stream. For you guys that are still working, we need to get that submitted. For those of you who were in the chat today, and I'm checking this against the results that I'm finding here, but for those of you that were in the chat today or even absent today, you need to make sure you get this thing done, and we'll pick up with more of it on Thursday. But yeah, there's the bell. That bell is early, isn't it? It should say 12:22 or 12:23. Whatever. I don't care anymore. Thank God I'm doing this enrichment thing at the end.